Pulsars. Pulsars are created when a star's core is being crushed by its own gravity. It's crushed very, very tightly and packed. The atoms are literally squished together. When this happens, it'll cause a supernova. This is a pulsar. That's usually what's left over after a star's death, a big star. Pulsars spin very, very fast, a few thousand times a second. And because of how fast they spin, they create two poles that emit a huge amount of radiation. You can see this radiation with infrared, gamma rays, and microwaves. And you can only see these if the light is directly pointed at you. Otherwise, you can't see it. It's kind of like a lighthouse. Pulsars are very dense and have a huge magnetic field that would rip you apart. The huge magnetic field of a pulsar is caused by the pulsar's insanely high density. This density is so high if you were on it, you'd be crushed to an atom-thin layer. Pulsars have very stable rotations, but they're unstable when they go around another pulsar. What happens when two pulsars orbit each other? When two pulsars orbit each other, they can cause their rotations to tip. This tip is similar to when two tops hit each other, or when two quarters hit each other. When these pulsars start getting closer and closer to each other, they will cause a huge explosion of neutrinos and gamma rays. When this happens, it creates a black hole. It's caused by the huge density of pulsars. What happens when a pulsar gets older? Well, the main thing that happens is the pulsar's rotation starts slowing down over millions and millions of years. As the pulsar's rotation slows down, its poles will start going away, and then eventually it will fade away and the pulsar will just be a little tiny dot of light and neutrons. What are pulsars made of? Well, they're literally just made of neutrons. That's it, neutrons. It's caused by the protons and the electrons to fuse together to make neutrons. Remember in the beginning when I was explaining how the core was being crushed to make a pulsar? Well, it's so extreme that it causes the protons, which are positive, and the electrons, which are negative, to fuse together to make neutrons, giving the name neutron stars. What if a star had an orbit around a pulsar? Well, two main things might happen, and it depends on the size of the star. Let's start with a big star. If a pulsar and a big star are orbiting each other, the pulsar's poles will literally blast away the star's gases. If it's a little star, the pulsar will suck up all those gases. There is a pulsar that does this exact thing. It sucks up the little star's gases. It's called the Black Widow's pulsar. Well, that's about it for pulsars. We're going to move on to black holes. But these are some pictures of the Black Widow pulsar. This pulsar moves through space really, really fast. It causes a shockwave that our telescopes can detect light years away.
What is a black hole? A black hole is a point in space where the gravity is so strong even light could not escape from it. Black holes are typically found in the middle of the galaxy or at the edge. A star that is way bigger than our sun will burn hydrogen much faster, and the pressure on the outside pushes on the core very, very hard. When the core of the star is being crushed, the core falls on itself, creating a black hole.
What do black holes do? Black holes are one of the strangest objects in space. They are really, really weird. They do quite a bit of things, and we'll explain it right now. So if we're going to talk about black holes, we have to talk about gravity. The escape velocity of Earth is 11 kilometers per second. Escape velocity is how much velocity you need to use to escape the gravitational pull of an object. Neutron stars have an escape velocity of 150 kilometers per second. That's half the speed of light. If you took the core and crushed it even more than a neutron star and made it even denser, the escape velocity will equal the same as the speed of light, which means light can't escape that. Nothing goes faster than light. So whatever happens in a black hole stays in a black hole. Whatever comes near it is doomed. So that's called the point of no return, which in other terms means the event horizon, or if other people want to call it the apparent horizon. It's called that because of Hawking radiation. I'll explain that a little later. But what you're looking at is the event horizon, where it's black. If you were falling towards a black hole, you would appear as you're falling slowly, and then you would disappear. So if you were to keep falling into a black hole, the first thing people are going to notice is that you're slowly slowing down, and then you stop, and then you turn red. This is called the gravitational redshift. This is when the light loses all its energy because the black hole's gravity is super strong. If you were to keep falling into the black hole, you would notice immediately that time is flowing by very, very fast. You would see the entire future of the universe unfold in front of you. That would be quite a scene. So, if you were falling into a black hole, your body would be stretched out like a spaghetti. It's called spaghettification. Whichever body part is closer to the black hole is going to be stretched out. Even a few centimeters difference, you will be stretched out like a spaghetti. Hawking radiation. Hawking radiation has to do with quantum mechanics. According to quantum mechanics, virtual particles will pop into existence and then annihilate each other. This happens for such a split second, they don't even count as real particles, so they're called virtual particles. Stephen Hawking thought of a place where these particles might be able to become real particles. He thought of the black hole. Just at the event horizon, the particles will get the chance to become real particles. One of the particles will fall in, the other particle will come out as radiation. This means the black hole is slowly losing energy, which means eventually it'll vanish and disappear. Alright, we gotta move on to quasars, but here are some more pictures of black holes. Quasars are pretty sweet. I think you guys are gonna get a kick out of it. Quasars. They are the brightest, strongest, and most energetic things in the entire universe. These things can outshine millions of galaxies, including their own. Quasars are created when a supermassive black hole, a young supermassive black hole, is taking in a lot of hot gas all at once. When this happens, it creates two jets of pure energy that are super bright. These pure energy jets are 20 times longer than our entire solar system. It's pretty dang sweet.